we're going to talk about vision. Okay, and a lot of people wear glasses or contact lenses. What kind of lenses do they wear? And most people wear this kind. The lens in your eye looks just like this. You have a convex lens in your eye, so it's a double concave lens, and it converges the light. So let's take a look at that. What happens in your eye is you have the outside of the eye where the pupil is, and the pupil is like the diaphragm of a camera where it lets different amounts of light in. And there are muscles on each side of that lens which will contract and relax and stretch the lens, and it changes the image, it changes the focal point. Okay, right now the focal point is back here. That's basically the retina of the eye. I'm going to simplify it just to make it easy. The retina of the eye is like the screen of our eye that receives all the light at a focal point, and it produces the images there. And then the retina sends on that message to the optic nerve. But you can clearly see how the light here is converged. Now there's a condition that we call nearsightedness, and I'm going to show you. Okay. If I have my lens here, I'm going to move this back a little bit. You can see the lens is here, the focal point is here. But what if the retina was actually back farther than that? So what happens then, the focus is too soon, it's before the retina. So a person like me can see objects up close, but when I look at a distance, they all converge too soon, so everything's blurry, everything's fuzzy. We call that nearsightedness or myopia. And watch what the fix is. This is interesting. Okay. Okay, let's see if I can. You see the pencil here? Yep, you can just barely see the pencil. The way to fix it is to use a diverging lens. So now I put a concave lens, and it puts a new focal point right back where my retina was. So let's take a look at this. So what I did is I moved the lens, or I moved the light by putting in a concave or diverging lens, and it moved the focal point backwards.